Imagine a universe where planets dance in perfect harmony, following precise mathematical patterns. Now, picture a man who, over 400 years ago, unraveled the secrets of this cosmic dance, forever revolutionizing our understanding of the cosmos. Welcome to another journey through time and space, where today we'll meet the genius who redrew the heavens, Johannes Kepler. I'm your guide on this fascinating journey through the universe. Today, we're diving into the life and work of one of history's greatest astronomers, Johannes Kepler. Born in 1571, Kepler lived during an era of immense transformation in scientific thought. His discoveries didn't just explain the movement of planets, they laid the foundation for modern physics. Get ready for a voyage to the heart of the scientific revolution. Before we embark on this cosmic journey, if you're as excited as I am about exploring the wonders of the universe, make sure to hit that like button and subscribe to Exploring the Universe. Turn on notifications so you never miss an adventure through space and time. Now, let's blast off into the extraordinary world of Johannes Kepler, the man who changed our view of the cosmos forever. To truly grasp the magnitude of Kepler's discoveries, we must first journey back to late 16th century Europe. Imagine a world where Earth was considered the center of the universe, with the sun, moon, and planets revolving around it in perfect circles. This was Ptolemy's geocentric model, which had dominated astronomical thought for nearly 1,400 years. Ptolemy's model, formulated in the 2nd century AD, was more than just astronomy. It was a cornerstone of medieval philosophy and theology, intertwining celestial mechanics with religious beliefs. But winds of change were blowing across Europe. The Renaissance was in full swing, challenging old ideas and fostering a new spirit of inquiry. In 1543, a Polish astronomer named Nicholas Copernicus proposed a radical idea, a heliocentric model that placed the sun at the center of the universe. This was revolutionary, challenged not just astronomical theory, but the very place of humanity in the cosmos. However, Copernicus's theory still couldn't perfectly explain the observed movement of the planets. The discrepancies were small, but significant. Planets like Mars seemed to dance to a rhythm that neither Ptolemy nor Copernicus could fully explain. It was in this atmosphere of intellectual ferment that our protagonist enters the stage. Johannes Kepler, a brilliant and curious young man, determined to unravel the mysteries of the cosmos. Born in 1571 in Wilderstadt, Germany, Kepler came of age in a world where the very structure of the universe was up for debate. The printing press was spreading new ideas rapidly, and the first telescopes were about to reveal wonders in the night sky. Kepler's era was one of transition, a bridge between the mystical, earth-centered cosmos of the Middle Ages and the vast, mechanical universe that was about to be revealed. Armed with a sharp mind, a deep faith in mathematical harmony, and access to the best observational data of his time, Kepler was poised to revolutionize our understanding of the heavens. As we delve into Kepler's groundbreaking work, remember, he stood at a unique moment in history, where ancient wisdom collided with new observations, creating the perfect conditions for a scientific revolution. Born in 1571 in the small town of Wilderstadt, Germany, Johannes Kepler's early life was far from easy. Kepler's childhood was marked by poverty and illness. He suffered from smallpox, which left his eyesight permanently impaired, and his family struggled financially due to his father's mercenary career. Despite these challenges, Kepler's brilliance shone through from an early age. His keen intellect and curiosity about the natural world set him apart. In 1589, Kepler's academic prowess earned him a scholarship to the prestigious University of Tübingen. There, he embarked on a journey that would change the course of scientific history. While Kepler initially studied theology, preparing for a career in the Lutheran Church, he soon found himself captivated by mathematics and astronomy. Under the tutelage of Michael Maestlin, one of the few Copernican supporters of the time, Kepler's passion for the cosmos was ignited. A pivotal moment in Kepler's life came in 1600 when he became an assistant to Tycho Brahe, the preeminent astronomical observer of the era. Brahe had amassed the most accurate observational data on planetary movements of his time, particularly regarding Mars. These meticulously collected data would prove to be the key to Kepler's revolutionary discoveries. Imagine Kepler as a cosmic detective, armed with the best data of his time and a brilliant mind, ready to unravel the secrets of the universe. Kepler's collaboration with Brahe was brief but crucial. When Brahe died in 1601, Kepler inherited his position as imperial mathematician to Rudolf II and, more importantly, gained access to Brahe's treasure trove of observational data. This was the turning point. With Brahe's unparalleled observations and his own mathematical genius, Kepler was now equipped to challenge the astronomical models that had stood for centuries. As we delve into Kepler's groundbreaking laws, remember, this was a man who combined meticulous observation, mathematical rigor, and a touch of mystical belief in the harmony of the cosmos. He was about to rewrite the very language of the heavens. Now, let's dive into Kepler's famous laws of planetary motion. These laws not only explained the movement of planets but also provided the foundation for Newton's theory of universal gravitation. Let's start with Kepler's first law, also known as the law of elliptical orbits. Kepler's first law states, "The planets move in elliptical orbits, with the Sun at one focus." This was revolutionary. It abandoned the idea of perfect circles that had dominated astronomy for millennia. Imagine the courage needed to challenge centuries of established thought. Since ancient times, from Aristotle to Copernicus, celestial bodies were believed to move in perfect circles. This belief was rooted in both religious and philosophical ideas about the perfection of the heavens. Kepler initially tried to fit Tycho Brahe's precise observations into circular orbits. But the data, particularly for Mars, simply wouldn't cooperate. After years of calculations and numerous failed attempts, Kepler finally realized that the orbit of Mars was not a circle, but an ellipse. This breakthrough came at a cost. Kepler had to abandon his own deeply held beliefs about cosmic circles. To visualize an ellipse, think of a rubber band stretched between two pins on a piece of paper. The curve formed is an ellipse, and one of the pins represents the Sun. This elliptical model explained why planets sometimes appear to speed up, slow down, or even move backward in the sky. It wasn't because of complex systems of circles upon circles, as previous models suggested, but simply due to the elliptical shape of their orbits. Kepler's elliptical orbits matched the observational data with unprecedented accuracy. It was a triumph of empirical science over philosophical preconceptions. This discovery was not just a victory for astronomy. It laid the groundwork for Isaac Newton's later work on gravity, helping to unify the physics of the heavens and earth. With this single insight, Kepler had redrawn the map of the cosmos. But he wasn't done yet. His next two laws would reveal even deeper truths about the dance of the planets. Now, let's explore Kepler's second law, also known as the law of equal areas. Kepler's second law states, "A line joining a planet and the Sun sweeps out equal areas during equal intervals of time." This law explains why planets move faster when they're closer to the Sun and slower when they're farther away. It's a consequence of the conservation of angular momentum. To understand this, think of a figure skater spinning. When the skater pulls their arms in, they spin faster. Similarly, when a planet is closer to the Sun, it moves faster to maintain its angular momentum. At perihelion, the closest point to the Sun, a planet reaches its maximum velocity. At aphelion, the farthest point, it slows down to its minimum speed. Yet, the area swept out by our imaginary line remains constant over equal time periods. This law was a major breakthrough. It provided a precise description of planetary motion that no previous model could match. It also hinted at an underlying force governing the planet's movements, though Kepler himself didn't fully understand the nature of this force. Finally, we come to Kepler's third law, the law of periods. Kepler's third law states, "The square of the orbital period of a planet is directly proportional to the cube of its average distance from the Sun." This law establishes a precise mathematical relationship between the time a planet takes to orbit the Sun and its average distance from it. It's cosmic harmony expressed in mathematics. This law explains why outer planets, like Jupiter or Saturn, take much longer to complete their orbits than inner planets like Mercury or Venus. The relationship is not linear, but cubic. Kepler discovered this law after nearly 2 decades of painstaking calculations. It was published in 1619 in his work Harmonics Mundi, or The Harmony of the World. This law isn't just a historical curiosity. It's still used today in calculating the orbits of newly discovered exoplanets around distant stars. These laws weren't just beautiful theories. They precisely explained astronomical observations, including the strange orbits like that of Mars, which had puzzled astronomers of the time. Kepler's laws matched observational data with unprecedented accuracy. They could predict planetary positions better than any previous system, including the Copernican model. Later, Isaac Newton would show that all of Kepler's laws could be derived from his theory of universal gravitation. Kepler had discovered the what of planetary motion. Newton would provide the why. With these 3 laws, Kepler had rewritten our understanding of the cosmos. He showed that the heavens operated according to precise mathematical rules, paving the way for the scientific revolution that was to come. Kepler's work extended far beyond astronomy. His discoveries laid the foundation for modern physics and scientific thought. First, let's consider how Kepler unified our understanding of the heavens and earth. In Kepler's time, it was widely believed that the celestial realm operated under different laws than the terrestrial world. This divide was deeply rooted in ancient philosophy and religious doctrine. Kepler showed that the same physical laws governing motion on Earth also apply to celestial bodies. This was revolutionary in an era when the heavens were thought to be governed by different, perfect laws. This unification was a crucial step in the scientific revolution, paving the way for a coherent understanding of the universe. Next, let's explore how Kepler's work inspired Isaac Newton. Kepler's laws were fundamental to Isaac Newton's development of his theory of universal gravitation. Newton essentially explained the why behind Kepler's laws. Newton showed that the force keeping planets in orbit was the same force that makes apples fall to the ground. Gravity. This insight was built directly on the foundation Kepler had laid. Newton's famous equation, F equals G, m1 m2, / r2, could be used to derive all of Kepler's laws, providing a deeper understanding of planetary motion. Perhaps most importantly, Kepler's work is a prime example of the scientific method in action. Kepler formulated hypotheses based on observations, tested them rigorously, and wasn't afraid to abandon ideas that didn't match the data. For instance, Kepler initially believed planetary orbits were circular and based on perfect geometric solids. Despite his personal attachment to these ideas, he abandoned them when they didn't fit the observational data. This commitment to empirical evidence over preconceived notions is a cornerstone of modern scientific inquiry. But Kepler's contributions weren't limited to astronomy and physics. He made significant contributions to optics, inventing an improved type of telescope. He also wrote extensively on mathematics, including influential works on geometry. Intriguingly, Kepler even wrote what is considered the first science fiction novel, Somnium, describing an imaginary journey to the moon. In this work, Kepler accurately described how the Earth would appear from the lunar surface, showcasing his ability to apply scientific thinking to speculative scenarios. From laying the groundwork for modern physics to inspiring space exploration, Kepler's legacy is vast. His work reminds us that scientific progress often requires both meticulous observation and bold, imaginative thinking. Johannes Kepler peered into the clockwork of the cosmos and glimpsed its underlying order. In doing so, he forever changed our understanding of our place in the universe. Kepler's discoveries are far from being just ancient history. They have practical applications that touch our lives even today. First, let's look at how Kepler's laws are crucial for space exploration. NASA and other space agencies use Kepler's laws to calculate the trajectories of spacecraft and satellites. When planning a mission to Mars or launching a new satellite, engineers rely on Kepler's laws to determine the most efficient path and the amount of fuel needed. For instance, the Hohmann transfer orbit, the most fuel-efficient way to move between two circular orbits, is a direct application of Kepler's laws. Next, Kepler's laws are fundamental in detecting and characterizing planets orbiting other stars. Astronomers use the wobble of stars or the dimming of their light to detect exoplanets. The periodicity and characteristics of these phenomena are analyzed using Kepler's laws. In fact, NASA named its exoplanet hunting space telescope Kepler in honor of the astronomer. This mission has discovered thousands of exoplanets using methods based on Kepler's work. Perhaps most surprisingly, Kepler's laws play a crucial role in a technology many of us use daily: GPS. Our global positioning systems rely on calculations based on Kepler's laws to determine the precise positions of satellites. When you use your smartphone for navigation, it's receiving signals from multiple satellites. The exact position of these satellites at any given moment is calculated using Kepler's laws. This allows your device to triangulate your position with remarkable accuracy. Without Kepler's insights, this everyday technology simply wouldn't be possible. Kepler's work reminds us that the quest to understand the universe can have profound and lasting impacts on our daily lives. From helping us navigate city streets to guiding spacecraft across the solar system, Kepler's laws continue to shape our world 4 centuries after they were first formulated. The next time you check a map on your phone or hear about a new exoplanet discovery, remember, you're experiencing the enduring legacy of a 17th century astronomer's relentless pursuit of cosmic truth. To deepen our understanding of Kepler's work and its significance, let's consider the perspective of Dr. Owen Gingerich, Professor Emeritus of Astronomy and History of Science at Harvard University and one of the world's foremost experts on Kepler. Dr. Gingerich argues, and I quote, "What makes Kepler truly remarkable is his unique combination of mathematical ability, scientific imagination, and a deep belief in the harmony of the universe. He was convinced that God had created the world according to a geometric plan, and this conviction drove him to seek mathematical patterns in celestial motions. This perspective helps us understand the motivation behind Kepler's tireless work. His quest for cosmic harmony wasn't just science. It was almost a spiritual mission to comprehend what he called the thoughts of God. Kepler's approach was unique for his time. While many of his contemporaries saw a conflict between science and faith, Kepler saw them as complementary. He believed that studying the universe was a way to understand the divine plan. This belief gave Kepler the perseverance to spend years poring over Tycho Brahe's data, seeking the underlying patterns. It was this combination of meticulous observation and a search for divine harmony that led to his groundbreaking laws. Dr. Gingerich also highlights the lasting impact of Kepler's approach. Kepler's work laid the foundation for the scientific revolution. His insistence on matching theory with observational data, even when it meant abandoning his own cherished ideas, set a new standard for scientific inquiry. This commitment to empirical evidence over preconceived notions became a cornerstone of the scientific method, influencing generations of scientists to come. Dr. Gingerich concludes, "In Kepler, we see not just a brilliant astronomer, but a bridge between the mystical, earth-centered cosmos of the Middle Ages and the vast mechanical universe revealed by modern science." His work reminds us that great scientific breakthroughs often come from unexpected combinations of ideas and beliefs. As we gaze at the night sky, we can appreciate how Kepler's unique vision, blending mathematics, observation, and a search for cosmic harmony, forever changed our understanding of the universe and our place within it. While Kepler's laws revolutionized our understanding of the solar system, new challenges have emerged in the field of astronomy and astrophysics. One pressing question is, how can we apply and adapt Kepler's laws to multiple stellar systems? In systems with two or more stars, the gravitational dynamics become far more complex. Astronomers are working to develop new models that build upon Kepler's work to describe these intricate cosmic dances. Another crucial area of research is the role of Kepler's laws in the search for habitable planets. Kepler's third law, in particular, helps us determine if a planet orbits in the Goldilocks zone. Not too hot, not too cold, but just right for liquid water to exist on its surface. This is crucial in our quest to find potentially life-supporting worlds. Perhaps most intriguingly, scientists are grappling with how Kepler's laws apply on galactic scales or in the presence of dark matter. The observed rotation of galaxies doesn't match what Kepler's laws would predict based on visible matter alone. This discrepancy led to the hypothesis of dark matter, opening up entirely new fields of research. Astronomers and physicists continue to build upon Kepler's legacy, exploring these and other fascinating questions about our ever-expanding universe. Who knows? Perhaps the next Kepler is out there right now, ready to revolutionize our understanding of the cosmos once again. As we face these new frontiers in astronomy, we're reminded that science is an ongoing journey of discovery. Kepler's work, centuries old, still guides us as we probe the deepest mysteries of the universe. Johannes Kepler, a man born into poverty in the 16th century, forever transformed our understanding of the cosmos. His three laws of planetary motion not only explained the orbits of planets but also paved the way for modern physics. Kepler's work bridged the gap between ancient astronomy and the scientific revolution, setting the stage for Isaac Newton's theory of universal gravitation and, ultimately, Einstein's theory of general relativity. Kepler's legacy reminds us that science is a journey of continuous discovery. Each answer we find opens the door to new questions, propelling us to explore the mysteries of the universe more deeply. As we look at the stars today, we see not just points of light, but a cosmos governed by elegant mathematical laws, a lasting testament to the genius of Johannes Kepler. Kepler showed us that the heavens are not beyond our understanding, but rather a realm that can be explored through careful observation and rigorous thought. His work continues to inspire scientists and dreamers alike, reminding us that with curiosity, perseverance, and imagination, we can unravel the deepest secrets of the cosmos. I hope this journey through the life and work of Johannes Kepler has expanded your horizons as much as it expands mine with each video. If you want to keep traveling through the cosmos with me, don't forget to subscribe to the channel and hit that bell icon so you don't miss any space adventure. Share this video with friends who also love the universe, and tell me in the comments. If you could ask Kepler one question, what would it be? Until next time, and remember, in the universe, curiosity is our fuel. Like, comment, share, and subscribe to Exploring the Universe for more cosmic adventures.